now that we know how to differentiate the natural logarithm, and it's not usually called this, but it's the natural exponential function, right? The base e exponent. We need to know how to do this if it's a different base, right? What if it's base 3 instead of base e, for example? Okay, well, for the logarithm, it's actually pretty straightforward, right? I want to figure out the derivative of the log base a of x. Well, to do this, all I'm going to do is I'm going to use my change of base formula. I'm going to rewrite this as a base e logarithm. Change of base formula says this is the derivative of the natural log of x divided by the natural log of a. So I could use my derivative rules. I can bring that natural log of a out in front, because remember, a is a number, so that's going to be a constant. So this is 1 over the natural log of a times the derivative of the log of x, and I know what the derivative of the natural log of x is. That's just 1 over x. So this is 1 over x times the natural log of a. Almost identical to the natural logarithm derivative, right? It just varies by a constant. Right? We have to adjust a little for the base being different, and the way we do that is we slip that natural log of a down there into the denominator with the x. So let's see how we can use this. Right? I've got a product rule situation here, right? Because I've got x, which I know how to differentiate, and the log base 2 of x, which I now know how to differentiate. So I'm going to use my product rule to do this. Y prime, or dy dx, is the derivative of x times the log base 2 of x plus x times the derivative of the log base 2 of x. All right, well, the derivative of x is just 1. So this is the log base 2 of x plus, let's see, x times the derivative of the log base 2 of x. This is 1 over x times the natural log of 2. And so look what happens here, right? These x's, they cancel. Right? This is the log base 2 of x plus 1 over the natural log of 2. That's it. There's my derivative. All right, so let me give you one, right? You can pause this if you like. Try working this one out, then we'll do it together. All right, so I'm seeing a chain rule situation here because I have the log base 4 of 2x. All right, that's going to make dy dx 3 times 1 over 2x times the natural log of 2 times the derivative of 2x. So I get 3 over 2x log of 2 times the derivative of 2x. That's 2, and now I get some canceling, right? These 2's cancel, and all that's left is 3 over x times the log of 2. That's it. All right, there's my derivative. All right, so how about exponential functions where the base is different? All right, well, here's how I'm going to do this. All right, here's how I'm going to do this. I want the derivative of a to the x. I'm going to write this in a little bit of a strange way. All right, this is equal to the derivative of e to the natural log of a to the x. Right, that they're inverse functions. Right, so e to the ln of something is just that something. All right, now let's see. I'm going to use my derivative or my logarithm properties. I'm going to take that x, bring it out in front. This is the derivative of e to the x ln of a. And I know how to do this, right? I know how to differentiate the base e logarithm. This is e to the x ln of a times the derivative of x ln of a. And okay, now I'm going to bring that x and put it back. I'm going to put it back where it came from, inside there. So this is e to the ln a to the x times the derivative of x times the ln of a. Well, the derivative of x is 1, and the ln of a, that's just a constant. All right, so this, now I'm going to put this back. E to the natural log of a to the x is a to the x times the log of a. And that's it. There's my derivative. And you see the exact same thing happened that we saw with the logarithmic function. They're both the same except for a constant. Right? The derivative of a to the x is a to the x, just like e to the x was. We just have to apply a little adjustment for the base being different. All right, so let's use this thing. Again, I've got a product rule situation here. Right? dy dx is x times the derivative of 3 to the x plus 3 to the x times the derivative of x. Let's see, that's x. The derivative of 3 to the x is 3 to the x times the ln of 3 plus the derivative of x is 1, so that's just 3 to the x. And let's see, I'll bring that 3 out. Let's factor this. Let's bring that 3x out. 3x, x, log of 3 plus 1. And that's it. There's my derivative. And so again, let me give you one, right? Take this one out, see what you can come up with. All right, so I've got a function of a function, cosine of 4 to the x. So I'm going to use the chain rule here and say dy dx equals minus sine of 4 to the x times the derivative of 4 to the x. That's minus sine 4 to the x. The derivative of 4 to the x is 4 to the x times the natural log of 4. Now let's just rearrange things a little bit. This is minus log of 4 times x sine of 4 to the x. And that's it, right? There's my derivative. Okay. Where to next? We do have a few more of these kind of base functions to look at. In the next lecture, we're going to talk about differentiating the inverse trigonometric functions, and we're going to use a very similar approach to how we found the derivative of the logarithm. Anytime we're talking about finding the derivative of an inverse function, I'm immediately thinking, can I use that formula? The derivative of the inverse is 1 over f prime of f inverse.